So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you for the confirmation, everyone. So before we get started, let me quickly introduce myself to you all first. So my name is Neeraj Kedia, and I have been working in this IT industry for more than 13 years now. So today we have gathered for a discussion mainly on how the Apache HBase is structured. So today we are going to discuss on why exactly we need HBase, what exactly is the main use of using HBase here, how the concepts of HDFS and MapReduce they are structured, and how we can use HBase as a part of our big data analysis. And then if the time allows, then we are also going to see a quick hands-on the HBase topic that we're going to discuss here. All right, so let's get started. So if we talk about why exactly we need HBase, then data we know will be accessed only in a sequential manner. So for example, when we are running a big data analytical job here, then for that we know that data is going to be run in a given sequence, and that's why we can use the HD-based storage structure instead of using the random access optimized SSDs. So if we talk about the HBase first, and again, HBase is what? HBase is basically a part of the Hadoop ecosystem and where we can make use of HBase in order to make sure we are having an effective data set structure in that too in different nodes, and then how we can fetch that for completing our big data analysis. Any huge data set will be processed sequentially in Hadoop, especially for the large volume of data sets, correct? Now, if we talk about a small history here, then HBase is modeled after Google's Big Table, which is used to collect data and serve requests for various Google services like Maps, Finance, Earth, etc. And Apache HBase began as a project by the company PowerSet for natural language search, which was handling massive and sparse data sets. And Apache HBase was first released in February 2007, and later in January 2008, HBase became a sub-project of Apache Hadoop. Now in 2010, HBase became Apache's top-level project. So if we talk about the HBase tutorial, then HBase is an open source, multi-dimensional, distributed, scalable, and no SQL database written in Java. So HBase, as we discussed, HBase basically runs on top of HDFS, as in Hadoop distributed file system, and it provides big table like capabilities to Hadoop. Now, it is designed to provide a fault-tolerant way of storing large collection of sparse datasets. Now, since HBase achieves high throughput and low latency by providing faster read-write access on huge datasets, it is used for the applications where we need to have a fast and random access to large sets of data. So basically, compression, in-memory operations, and Bloom filters like we have for data structures, which tells whether a value is present in a set or not. So these features are available here to fulfill the requirement of fast and random read-write operations. Now, we can understand this by a simple example. Let's say a jet engine generates various types of data from different sensors like pressure sensor, temperature sensor, speed sensors, etc., which indicates the health of the engine. Now, this is very useful to understand the problems and status of the flight. Now, continuous engine operations generates 500 GB of data per flight, and they are 300,000 flights per day approximately, right? So engine analytics applied to such data in near real time can be used to proactively diagnose problems and reduce unplanned downtime. And this requires a distributed environment of handling large data volume with fast random read and writes for real-time processing. And here HBase comes to the rescue. So we are going to talk about HBase again as we proceed further. Now, if we talk about the main difference between HDFS and HBase, then we know that HDFS is what? HDFS is basically a Java-based distributed file system that allows us to store large data across multiple nodes in a Hadoop cluster. It has its own well-defined architecture put in place. So HDFS, we can say it's It's basically an underlying storing system for storing data in the distributed environment. And HDFS is basically a file system, whereas HBase is a database itself, similar to MySQL. Now, as both HDFS and HBase stores any kind of data that is structured, semi-structured, and unstructured in a distributed environment. So let's look at the differences between HDFS and HBase. So we have seen again, as we can see here, HBase provides low latency access to small amounts of data within large data sets, while HDFS provides high latency operations. And HBase supports random read and write, while HDFS supports worm. Worm as in write once and read many or multiple times. And HDFS is basically, or we can say primarily, accessed through map-reduced jobs, while HBase is accessed through shell commands, Java APIs, REST, Avro, or Thrift APIs. And HDFS stores large data sets in distributed environment and leverages batch processing on the data. For example, it would be helping any e-commerce store to store millions of customers' data in a distributed environment, which grew over a period of time. For example, maybe it may be 4, 5, or 6 years old. Then it is going to leverage batch processing over data and analyze customer behaviors, patterns, and requirements. So then the company could find out what type of product customer purchased in which month, and it simply helps to store archive data and execute batch processing over it. So while HBase stores data in a column-oriented manner, where each column is stored together so that reading becomes faster and leveraging the real-time processing. For example, in a similar e-commerce environment, it stores millions of product data. So if we search for a product among millions of products, it optimizes the request and search processes. So producing the result immediately, or we can say in real time setup. So again, and that exactly is what we are going to discuss when we start our session altogether on top of big data, where HBase is a fully focused module. Now, as we know, HBase is basically a distributed over HDFS. So combination of both can give us great opportunity to use the benefits of both. In a tailored situation, we can use for example, here we can also take example for Facebook Messenger case study as well, in case you want to understand it further. So if we talk about Facebook, now, Facebook messaging platform shifted from Apache Cassandra to HBase in November 2010. So again, that is not the part of the content here, but anyways, I'm going to give you a small overview from that. So Facebook's messaging platform was transferred to HBase back in November 2010. So Facebook Messenger combines messages, emails, chats, and SMS in a real-time conversation. So Facebook was trying to build a scalable and robust infrastructure to handle a set of these services. Now, at that time, the message infrastructure handled over around 350 million users, sending over 15 billion person-to-person messages per month. That was a humongous amount of data. And the chat service supports over 300 million users who send over 120 billion messages on a per month basis. So by monitoring the usage, they found out that two general data patterns were observed. So a short set of temporal data that tends to be volatile and an ever-growing set of data that rarely gets access. So Facebook wanted to find a storage solution for these two usage patterns, and they started investigating to find a replacement for the existing messaging infrastructure. So earlier in 2008, they use open source database like we have Cassandra, where it is basically an eventual consistency key value store that was already in production, serving traffic for inbox search. Now, their teams had a great knowledge in using and managing a MySQL database, so switching either of the technologies was a serious concern for them. And they spent a few weeks testing different frameworks to evaluate the clusters of MySQL, Apache, Cassandra, Apache, HBase, and other systems. And the ultimate selection was done for HBase. Now, as MySQL failed to handle large data sets efficiently as indexes and data set grew large, the performance suffered. and they found Cassandra unable to handle difficult pattern to reconcile their new messages infrastructure. All right. So basically, there were multiple problems faced here, and that was all resolved by using HBase that we are going to discuss as we proceed further. So if we talk about the HBase storage mechanism, then HBase is what? HBase is basically a column-oriented database. So the table schema defines only column families and key value pairs. So that's why we can say HBase is what? HBase is what? A simple NoSQL database. So it's not an SQL database. It's not a part of the relational database service, but it's more like a complete NoSQL database service. Like we had DynamoDB, we have Cassandra. So these are what NoSQL database is. So for example, here we have defined a row ID, and then we have column family as name and role. Now, here, if you talk about the HBase primary features, then HBase, first of all, can be scaled linearly. That means, again, we can increase the capacity, we can increase this number of rows that we can store here at any point of time. Then it also supports auto failure support by maintaining a standby structure. It offers consistent read and write, and we also have the inconsistent read and write for support also available. Then we have, and then again, it can be easily integrated with Hadoop because again, it is one of the primary tool being used here. And again, it offers a good Java API support as well. And now, and then if we are using HBase and to increase the resiliency of the architecture, we can simply replicate data from one part to the other. Now, if we talk about, let's talk about the Apache base architecture. So as we know, HBase is what? HBase is basically a column-oriented NoSQL database. Now, although it looks similar to a relation database which contains rows and columns, but it is not a relational database, right? So relational databases are now row-oriented while HBase is a column-oriented structure. So let's understand the difference between column-oriented and row-oriented databases. So if we talk about row-oriented versus column-oriented database, then row-oriented databases store table records in a sequence of rows, whereas column-oriented databases store table records in a sequence of columns. That is, the entries in a column are stored in a continuous location on disk. All right. So it's basically here we can assign regions to the region servers and take the help of Apache Zookeeper. So basically we are also going to handle load balancing of regions across region servers. And then we can maintain the state of the cluster by negotiating the load balancing itself. And then it allows a good communication with the client and handle data related operations. It also allows us to handle read and write requests for all the regions under it. And then it decides the size of the region by following the region size as available here. So if you talk about region, then a region contains all the rows between the start key and the end key assigned to that region. So HBase tables can be divided into a number of regions and in such a way that all the columns of a column family is stored in one region. So each region contains rows in a sorted order. So many regions are assigned to a region server, which is responsible for handling, managing, and executing reads and write operations on that set of regions. So to summarize, we can say a table can be divided into a number of regions, and a region is basically a sorted range of rows storing data between a start key and the end key. And a region has a default size or 256 MB, which can be configured according to the need. And a group of regions is served to the clients by a region server. And a region server can approximately serve 1,000 regions to the client here. Now, starting from the top of the hierarchy, we can explain in detail about the Edge Master server, which acts similarly as a name node in HDFS. And then moving down in the hierarchy, we are going to talk about the Zookeeper and Region server as well. So as a part of the architecture, we also have Edge Master as well. So Edge Master is also used for handling a connection of region server which resides on a given data node. So we can say HBase master provides DDL as in data operation and operations to create and delete tables. And it also assigns regions to region servers, as we can see in the previous diagram that we had taken a look at. And then it coordinates and manages the region server, similar to a name node managing data nodes in HDFS. And then assigns it assigns regions to the region servers on startup and reassigns regions to region servers during the recovery and load balancing. And then it monitors all the region servers instantly, and that is focused on the clusters from the help of Zookeeper itself. And it performs recovery activities whenever any region is down. And it provides an interface for creating, deleting, and updating tables as well, as and when required. All right. So now, as a part of a hands-on, we are going to see how exactly HBase is structured. So for that, we are going to make use of the Cloud Data Manager here. Here we can get the access for getting the access. HBase is currently, we can say, available in the Cloud Data Manager as well, in case we do have the access to HBase. And again, in case we don't have, first of all, we can get the access to Cloud Data Live, and we'll be able to work on the HBase package as well once we have installed it. So Hue is something that we don't know is used basically used as a complete set. We can say a complete file manager itself. And here we can see HBase, where we can see the entire base statistics. For example, if in case we have multiple instances up and running, for HBase, we can see the list of all the instances here from the GUI, where we can see what is the role type, the host, where exactly they are located here with the commission state and the role group available. We can see the entire maintenance mode, which one are in maintenance mode, which one again are currently up and running as default, and what exactly are the health tests being conducted, and how many instances are currently in file descriptors, in compassion queue size as per the detailed report. Same way here we can find the configurations for these instances as a part of the HBase cluster. So we can now here we can see currently we have how many gateways, the HBase REST servers, the category in terms of advanced logs, metrics, monitoring, and if you want to use Zookeeper for monitoring the service here, then here we can define the threshold as well, which means how quickly we want to monitor it. And then we can define the Zookeeper service, the HBase client write, HBase client client pause. So here we can define the write buffer, here we can define the client pause, here we can define the client retires number, the scanner caching here. We can define the key value, the maximum size of the key value. We can define the frequency for the walkthrough, we can say the wake frequency. We can define it for the thrift and the proxy user, and here we can define the super users, RPC timeout, Zookeeper connection retires, and then the Z node root server. So that means here we can see the entire configuration defined for the nodes are currently available in the configuration tab. Now to run some common commands here, we can simply see the list of all the commands that has been executed. And in case there have been some recent commands executed on this one, then here we can simply see it. And here we can see the entire table statistics. If you want to work on the HBase UI, then here we can simply click on HBase Web UI, and then we'll be getting the access in case we do have the access to this. So let's log into the console here so that we can start getting the access. Just a moment. Let's log into our console here. So here we can log in via the credentials here. Let's do that. Just a moment. So here, once we have logged in, again, we can simply type in different commands here as the HBase. Now, for example, just to cross-check if the HBase configuration has been properly defined or not, we can simply define the configuration for HBase. And then we can write any commands once we have the access so that we can get started accordingly. Now, in case we have, now currently this is basically the default console that we have. If you want to work on the HBase shell in case it has been configured, then we can use the HBase shell, and then this is going to simply integrate the HBase shell here, and now we can simply get started. So whatever HBase tutorial code we want to work on, we can simply define the status. For example, to check the status for HBase, we can simply use status, and then status report for all the nodes up and running. So you can see here we have one active master, 0 backup masters, 1 server, 0 dead, and the average load here. So 763.67 is the average load. And to see the current version of HBase being returned, we can use the concept as version. And then we can see the current version has been 1.20, 5.111. And then we can see the timestamp as well, which has been done when it was properly installed. And then to see the list of all the commands for tables, and here we can define the table, and then here we can define help. So this is basically going to simply return all the help by a simple hyphen altogether. So here this is going to simply return all the statements which we can use along with table, along with the configurations defined here for HBase T1. So now, for example, suppose here we want to see the return, we want to see the result in terms of who's actually we are. So here we can use who am I, and then we are going to see the user credential, and this user is currently a part of which user group. We can also see it as a result being specified here. And there are multiple now. Again, if you want to work on the entire DDL part here, so for example, suppose if you want to create a simple employee table here, right? So we can do that since we are in HBase here. So we can define the entire create table employee here. For example, suppose our goal here is to create simple table for employees. So here we can define here, we can clear the screen. Now, to create an employee table here, for example, suppose first we come out, and then we can simply again reopen HBase shell. So here we can see the list of now to create a table here. For example, here we can define create, and suppose we want to create something for employee. So here we can define employee. Then we can define another column, suppose as name, and then we can define, suppose here we can define a simple ID column here. Now here we can define ID, and let's say here we also want to add what we want to add something called as designation. Then we want to add another column, suppose for salary, and then we can add one for department as well, department. So basically here we are going to simply create one table for employees where we are going to define data sets such as name, ID, designation, salary, and department. So if the table already exists here, we can create a new table. Let's suppose here we can, instead of employee here, we can name it as employee one. So as you can see now we have changed the name here itself as employee December, because again earlier the tables for employee one and employee has already been created in the past, so we cannot recreate that. So here we define a new name. And now if you want to start working on one specific table, so here we can define table, and then we can define which table we want to work on. Suppose employee December 20 that we have defined just now. So here we can define the table name as well, whatever we have defined. Now, since we have switched to the table here, we can see the table name is also being returned to us. That means now we can start working on this particular table itself, right? And now suppose let's say here we go back to the same Cloud Data Manager, we will be able to see a new region will also be created for the table that we have defined just now. All right. So now if you want to see the entire list of all the tables here, then here we can use command as list. And you can see currently there are multiple tables being created here. So we can see the list of all the tables being returned to us. And same way, if you go back now to see the details in our HBase dashboard, we can go back, and in our HBase dashboard, here we have to go to a simple region dashboard here. So let me show you how exactly we can go ahead. And so here we can see the status here. And then for the HBase, we can see the region here. We can see the report for every region that is currently available here. And now to see the report for which all regions have been created, we can go to the section for status, and then we will be able to see the region in which it has been deployed, so that we can have a quick insight on it. So that's how we can get started working on any HBase environment as per the setup required. And same way if you want to work on creation of more tables here, because again at the end this is what a simple NoSQL structure is. And suppose we want to work on the SQL structure, we can simply get down and can, so these are the list of all the tables currently available here. Now for example, suppose let's say for any reason, suppose we want to disable the current table that we had created here, right? So here we can simply type in as disable. I think it has frozen, so let's refresh the connection. Just a moment. We can again restart HBase. HBase shell. Suppose let's say here once we have moved into that HBase shell, suppose here we want to disable one particular table. So here we can use disable, and then suppose here we want to disable December employee December 20 that we have created. So here we can define a table name. And if we want to disable this row here, we don't want to use this as a part of region right now, then we can simply do that. Or suppose here we want to work on one specific table, then we can define the table and the name for it. Suppose here we have employee December 20, and we can see the entire report also being generated here. So we are going to work on more references as we proceed further. So let's say here we want to create another script here. For example, let's say here we can come out and let's say we clear the screen here. Now we want to work on some other scripts here. For example, here we define okay how we can create a table here, how we can disable multiple tables. Now for disabling multiple tables, we are going to simply use a small statement. Now we can disable a single table that we had done, or we can use multiple tables for again if we have requirement of disabling multiple tables at once, then we can simply use that statement as well as and when required. So the create table was what we had seen before. So let's suppose we do one thing. Let's create another table as create, and then we can disable all the tables here. So here we can define suppose as employee for employee, and that will for December as a name. And then we want to create another table having suppose its own name. Then we may have value for ID. Then we may have value for designation. Same way here we are going to have value suppose again for salary, and one more for the department. So here we can define this table by this name here, and then we will be able to work on this specific table itself. So here we can disable. Now if we want to disable all, so here we can define statement as disable all, and then if you want to disable all the tables having the prefix as e and then any specific table structure, then we can define the parameters here. So this is going to find out all the tables starting from e here, and again it can continue to any of the elements that you want to define here. So for example, if there are multiple tables by the e, then they all are going to be disabled for now. And suppose if you want to see the list of all tables having this structure, then we can simply press enter, and then we will be asked a simple confirmation if yes, we want to disable all the two tables or not. And in case there are no tables created as of now, then this is going to be simply returned as a blank value. And if you are looking to put any, or can say add any entries to any of the table, for example, we had defined table as employee December, right? So now we want to put any entries here. So here we can use the command as put, and then we want to have to define okay, we in which table we want to put the details. Here we have employee for December. Now in this table, we have to define the values as well. For example, here name is suppose John. So here we can define the name as John, and then we can here we have what? Here we have name. So we can keep on defining multiple tables, multiple values as part of the requirement here. We can define any values as part of the requirement. So for example, suppose here we want to define any specific value here, for example, name, full name, or we want to insert any values as a part of the NoSQL database. So we can also define that. For example, here we can define the name. Next, we can define, suppose the name as our full name. So here we can define full name, and suppose here we can define full name as suppose John Hopkins. So again, it can be any name, and if we run this on this current table that has been created, we will be able to see the entry is going to be updated here. So that's how we can start manipulating it. And again, if you want to add more details here, we can define this for suppose same way we also want to import, or we also want to insert the details for age as well. So here we can keep the name as same, and then here we can define the present. For example, here we can define present age. Instead of full name, we can go for present age. Suppose age as our present age, And here we can define, by suppose the present age is what? Present age is suppose, let's say 24. Here we can find present age. And then we can define the course, or we can say any name that we want to be referred. So that's how we can keep on adding entries here. Thank you so much for joining, guys, and have a great day ahead. Take care. Bye-bye.